Now we will discuss about the extraction of metal from its ore. Metals, what we get from the interior of the earth, that is earth's crust, consist of lot of impurities. That impurities like sand, soil, etc., which is called gangue. So gangue has to be removed, and afterwards, in order to concentrate the ore, lot of steps are there. So according to the concentration of the ore, in order to concentrate the ore, the metals are classified into metals of high reactivity, metals of medium reactivity, and metals of low reactivity. Now this metals of high reactivity, that is electrolysis of molten ore. Molten ore is electrolyzed and then you will get the pure metal. And when coming to this metals of medium reactivity, it is classified into carbonate ore and sulfide ore. If carbonate ore is present, the calcination method is used. Sulfide ore is there, then roasting method is used. After calcination and roasting, oxides of metals are formed. Then on reduction and finally purification, you will get the pure metal. Then metals of low reactivity. In this metals of low reactivity, sulfide ore is normally found on roasting, gives a metal, and finally in order to get the purified metal, refining process is used. Now let us discuss one by one. First we will discuss about metals of low reactivity, how it is extracted. First we will take the example of mercuric sulfide. Mercuric sulfide, HGS, on roasting, it gives mercuric oxide and sulfur dioxide. This mercuric oxide, which on further heating, it gives mercury and oxygen. So this is the first method how this low reactivity series is done. So in order to balance the equation, so this is because sulfur is 2, so you have to put 2 over here, and mercuric oxide on heating gives mercury and oxygen. So in order to balance the equation, to put 2 over here. Now let us discuss about the reaction in which the middle, that is of middle reactivity series. For middle reactivity series, that is normally the ore is found in either sulfide or carbonate form. If it is in the form of sulfide ore, for example zinc sulfide on roasting. Roasting means heating in the presence of oxygen. Heating in the presence of oxygen, which is called roasting. So here you will get a zinc sulfide gets converted into zinc oxide plus sulfur dioxide, which on reduction, the zinc oxide on reduction with carbon, it gives zinc and carbon monoxide. Finally, you will get the zinc metal. And in the middle series, even if it is in the carbonate state, that is for example magnesium carbonate on heating directly, it gives magnesium oxide and carbon dioxide. This method is called calcination. Now what is mean by this roasting and calcination? Roasting means heating ore in the presence of oxygen in order to convert, that is sulfide ore into oxide ore. And calcination means heating in the absence of air in order to convert oxide or carbonate into oxide ore. This is how this calcination and this roasting is done. Now let us discuss about high reactivity series. Now suppose if it is in the high reactivity series, how it is extracted. Metals are extracted in high reactivity series. For example, sodium chloride. Sodium chloride, sodium is a highly reactive element. So, calcination, roasting, all these methods cannot be used to extract this highly reactive metal. So, in this case, electrolysis process which is used. So, electrolytic reduction, actually electrolytic reduction is used. For example, sodium chloride, sodium NaCl. It is sodium chloride, it is in the ionized form, Na plus and Cl minus. Electrolytic reduction, you know that about anode and cathode. Anode and cathode. Now, anode is positive and cathode is negative. So, due to electrolytic reduction, sodium is a positive charge, so it goes to the cathode, and chloride will move to anode. Opposite charge will be attracted. Sodium will move to cathode and chloride ion will move to anode. Now, you can see sodium sodium moves at cathode. So, what reaction takes place at cathode? Now at cathode, sodium is already lost electron. So Na plus means it is already lost electron. So it takes back that electron and forms sodium metal. At the same time, anode chloride ion is gone. Anode reaction, chloride is moved at anode, and chloride ion Cl minus, that is already excess of electron. It gives back the 2 electron and form chlorine gas. It forms chlorine gas. This is how the electrolytic reduction takes place. So, for the electrolytic reduction, during this electrolytic reduction, ions moves to cathode and anode. Depends upon this. Positive charge will move to negative electrode and negative charge will move to positive electrode. So, anode and cathode, sodium and chloride ion will be formed. And this is how the extraction of metal takes place. And this natural metal, what we get from the crust of the earth, which contains lot of impurities. So, impurity has to be removed step by step. And that procedure which is called the concentration of the ore. Our concentration of the ore have different steps as we have discussed over here. 3 different categories metals are classified: reactivity, low reactivity, middle reactivity, and the highest reactive elements. According to that, the methods are employed. Then after completing this, the pure metals has to be purified.